All right, these are the circular motion notes for physics, and they are a part of our Unit 7 information. So if you like to set up your notes as far as division, then you would have vocabulary, then you'd have T and F with example 1, then you'd have linear speed with example 2, and the vocabulary includes period, frequency, revolve, rotate, and centripetal. Again, it is period, frequency, revolve, rotate, and centripetal. That's what's written on the board in my classroom. Okay? Then the other side of the notes would be UCM, which stands for Uniform Circular Motion, and Centripetal Acceleration with example 3, and Centripetal Force with example 4. All right, so a vocabulary word, revolve. Revolve is to move around an external axis. Rotate is to move around an internal axis. If we are thinking about the moon and the earth does this once a day. Would it be revolves or rotates? Well, because it has an internal axis, it would be rotates. The earth does this once a year. Because it's rotating around the sun, which is an external axis, that would be revolves. And then, so the moon does this around the earth, and that would be it revolves around the earth because the earth is an external axis. Now the period, which we use the symbol capital T, of an object is the time it takes the mass to make a complete revolution or rotation. Another way I like to say it is it's the time for one cycle to happen. So it's the time for one revolution or the time for one rotation. Now period, frequency is the variable letter lowercase f because capital F is for force, and it is the number of turns per second. So when we look at units for period, since it's a time will always be in seconds, and frequency, since it's the number of turns per second, is known as hertz, which is actually 1 over a second, or second to the -1 power. Now, period and frequency are reciprocals of each other, and a way to actually write these formulas are, one way would be to say that the period is the time divided by the number of, and then frequency would be to write the number of rotations, revolutions, vibrations, whatever we want to talk about, divided by time. All right, so since they're reciprocals of each other, notice they are just the flip-flop of each other, or the inverse. Another way to write it would be that F equals 1 over T, or we could write that as, and I'll write it over here since I don't want to move my stuff around. That messes up my recording. So 1 divided by F. So again, both of those are formulas. This should be in the T and F square on your formula or on your notes. And the period and the frequency are definitions. So example 1, I have a spring that's going to make 12 vibrations in 40 seconds. So I want to find the period and the frequency. So we said frequency was the number of in a certain amount of time. So I could say the vibrations divided by time, which would be 12 vibrations divided by 40 seconds. When I do that in my calculator, it's 0.3 hertz. So to find the period, I would just take the reciprocal of that, 1 over F. I could also do 40 seconds divided by 12 vibrations. Either way, if I take the reciprocal of the frequency, then that's 3.33 seconds. If I do 40 seconds divided by 12, that's also 3.33 seconds. Now the period is the time for one complete revolution. So the linear speed or tangential speed, can be found by dividing the period into the circumference. What we've talked about so far is linear speed, as in something going in a straight line, but we're now talking about things going in circles. So if we take that circle and we break it and pull it in apart, then it's really just the circumference of the circle is the distance value. So in the past, we found speed as d divided by t. That distance now is just going to be the circumference of the circle, so that would be 2 pi r, and the time would be listed as the period. Since period and frequency are reciprocals of each other, we could also write this as 2 pi equals r times f. Now the units for this would be just like we would do for velocity normally. It is meters per second, okay? Because the r will be in meters and the period will be in seconds. So example 2, I have a 2 kilogram body. It's tied to the end of a cord that's whirled in a horizontal circle that has a radius of 2 meters. If the body makes 3 complete revolutions every second, I want to determine its period and its linear speed. Well, I know its mass is 2 kilograms. I know its radius is 2 meters per second. And the 3 complete revolutions every second is the frequency. So remember, to find period, I would just take the reciprocal of the frequency. So 1 over frequency. So 1 divided by 3 would give me 0.33 seconds. Now to find the velocity, I could do 2 pi r divided by t, or I could do 2 pi r multiplied by f. If I do the 2 pi r divided by t, I want to use the unrounded version of this, okay, in my calculator. So I do 2 times pi. You'll use the pi button, which is right next to the h down below on your keypad in your calculator. So you do 2 times pi times 2 divided by the unrounded answer of 0.3333 repeating in your calculator, which would give you 37.70 meters per second rounded. Okay? Now, when we talk about uniform circular motion is the motion where there's no change in speed, only a change of direction. If this goes flying off, this ball goes flying off the curve, then it's going to go in a straight line path. That straight line path is known as its tangential speed. This V1 and this V2 are the same magnitude, but they are different directions. So that means that it's the same speed, but a different direction. Okay? So centripetal acceleration is talking about the fact that since there is a change in direction, there is a change in velocity. The velocity magnitude is the same, but the direction is different, which makes the velocities different values. If velocity changes, then acceleration is occurring. And if acceleration is occurring, then you have something called centripetal acceleration. All right? To calculate centripetal acceleration, we use linear velocity and the radius. So the formula for that will be v squared over r. Okay. Now I also gave you some other formulas for v squared. So that would be if we substituted those in and squared them and divided them by r, then we could get things that look like this, which would be 4 pi squared r over t squared. Or we could get 4 pi squared r times f squared. So either one of those or any of these 3 formulas could be used to calculate for centripetal acceleration. Now, a ball is whirled at the end of a string in a horizontal circle that's 60 centimeters and a radius and a rate of 1 revolution every 2 seconds. I want to find the ball's centripetal acceleration. Well, to do that, I have to identify what I have first, and I have a radius that's 60 centimeters, which has to be converted to 0.6 meters by dividing by 100 centimeters. And then I know for every 1 revolution, they're in 2 seconds. So that actually is 0.5, and that is in hertz, which would be a frequency. Or I could say that since it is 2 seconds for every 1 revolution, that is also period. So the period would just be 2 seconds. So I could use either one of those. Now, to find centripetal acceleration, I have to use the equation. And I want to go ahead and move that over there, so I'll move it real quick. So I have R equals 60 centimeters, which becomes 0.6 meters. And then I have a frequency of 1 over 2, 1 revolution over 2 seconds, which is 0.5 hertz. And then I had a period of 2 seconds divided by 1 revolution, which is 2 seconds. Okay? Well, I don't have a V value, but I did give you a way to find V, which I could say it is 2 pi r over t. Okay? If that's the case, then I can substitute it and say 4 pi squared over r is 2 pi squared times r over t squared, which I could substitute r's value and t's value, and I would end up with 5.92 meters per second squared. Okay, I could have also done 4 pi squared r times f squared. Those would have given me the same values also. Okay. Now, centripetal force, which is the last thing that we're going to cover over circular motion for this unit, is an inward force that's necessary to maintain our uniform circular motion. And so that's defined as our centripetal force. I will tell you, centripetal force is not its own force. It's created by other forces, all right? So it's a force that might be like a tension force or a frictional force, but it's always a force that's going to the center of the circle. And so that's what creates your centripetal force. From Newton's second law, the centripetal force can be given by, Newton's second law says F equals ma. So if we want to talk about centripetal force, then we'll just use the centripetal acceleration multiplied by the mass. And since we know how to solve for centripetal acceleration, we could expand that out to be F equals mv squared over r. All right? A lot of y'all felt this force when you're on a merry-go-round. Okay, you've also felt this force when you go around a curve in a car. All right. So again, it's that inward force, and we can have it as F equals ma. We could also have it as F equals mv squared over r. But because I gave you other substitutions for AC, we could have it as m equals 4 pi squared times r over t squared. We could even have it as m equals 4 pi squared times r times f squared. So all of those work as a centripetal force formula, depending on what variables you've got. So you could use all of them. So all of them should be written down on your notes, and if you want to then put them on your note card, which you're going to be allowed to use possibly if we're doing that this year on your test, then you could do that as well. All right. Okay, we're going to skip past that. It is, actually, I'll go ahead and let it play. So this is from the movie Cars by Disney, and it's an example of our, and that's the end of the school day, but it's an example of our centripetal force. Sorry, I lost train of thought. Okay, so he didn't have any All right, so because of his lack of centripetal force to go around that curve, he did continue in a straight line path that was tangent to the circle, which that would be that linear speed that if it goes off the circle, it goes in that straight line path. All right. So my example 4, I have a 1,000 kilogram car. It's going to round a turn that has a radius of 30 meters per second at a velocity of 9 meters per second. I want to know how much centripetal force is required to do this. So I know my mass, I know my radius, and I know my velocity. So my centripetal force would be my mass times my velocity squared over r, which would be my 1,000 kilograms multiplied by 9 meters per second squared divided by 30 meters. So when I do that in my calculator, I would get 2,700 newtons. The big question is, where does this force actually come from? Because again, centripetal force is not an actual force. It's created by other forces, but it's always that inward force. And if you notice, the frictional force is pointing towards the inwards of the circle. So that would actually come from the force of friction between the tires and the road. All right. So this is the information that you need to know about circular motion for your test on Unit 7. If you have questions, please let me know.